Hello, and welcome to Tech presented by Kaizen, where we will explore common cleaning questions and answers. This session has been pre-recorded and will include additional FAQs related to this specific topic at the end of the presentation. We hope it is 15 minutes well spent. Let's get started. I would like to introduce Kaizen's own Eric Bromley.
Thank you, William, and welcome everyone to today's edition of Kaizen's Tech to Tech series. Today I'm going to talk a little bit about ferrous metal part cleaning with just water, and is it in fact good enough? In some cases it is, but in many cases it's not. So some of the topics that we're going to be discussing during this session will be the typical water-only processes that are being used now, water quality issues or water quality matters that is very high, the expectations of the results on what you should expect if you're using water only versus using a chemistry. Some of the areas that you should be mindful of when using water for cleaning, and of course the ever-present corrosion concerns that if you have not seen it yet, you will soon. So some of the typical water only processes, most of them are spray and air. There are some that are cabinet style or immersion, but most of them are spray and air, and with or without drying, and that would be a blow off knife dryer or sometimes a cow rod heater type dryers, but usually they're pretty simple operations. Single pass processes, and what that means is that the water is used one time, and what we refer to it in the business is a full cascade process, where the water comes in from the rinse or separate feed into the wash section. It's sprayed on the parts and then it goes immediately to drain. That is fairly common in some of these cleaning systems. Particular filtration and oil separation are always fairly common. Particular filtration would be for to maintain good quality going to the pump so the pump itself doesn't get damaged. And oil separation obviously used to remove any floating soils in the bath themselves. They could be a wheel or a belt or a coalescer or a quiet tank. There's different types, but they all function pretty much the same. And most of these systems are heated because they don't have the chemistry to rely on for the cleaning, so they rely on getting the parts and the water as hot as possible to solubilize the soils. But again, some of them are not, but most of them are heated. As far as the water quality, if you're using water only, then water quality is very important because as the phrase goes when working with any computer systems, garbage in and garbage out. And it would be the same here. If you're using poor quality water, then you can't expect to get good quality clean parts. Part of having the good quality water is to pre-filter the incoming water through a chelate and carbon bed. Now, the chelate bed will remove the heavy metals, and the carbon will help to remove the organics. And the heavy metals would cause spotting and streaking, or not streaking, I'm sorry, they could cause spotting and poor adhesion, and the carbon will remove the organics, which helps with keeping the tank clean itself. In process, pump filtration is also important, as I mentioned a little bit on the previous page. It's very important to have good protection for the pump itself because as it pulls in the water, it's going to it could damage the impeller pumps, and it can also plug the nozzles and the filters and things of that nature. So good quality filtration is very important. Oil separation is also very important, although many water-soluble oils and coolants, just by their makeup, they solubilize in water, so they don't split or come to the surface like other typical oils and coolants may. So oil separation can be a problem, but it is still an important part of the step and should always be included and maintained. And back to the carbon, the pH and bacteria growth in water-only systems can be a problem. If the system is not a full cascade, where the water is used over and over again, where it's sprayed and captured in a tank and then pumped back through, then that bacteria can grow in those tanks, especially if they're heated and you're adding the coolants and the oils. A lot of times those aren't really the cleanest materials to deal with. So pH and bacteria growth can be an issue, and it can damage the parts and it can damage the pump if it's left long enough. and the bacteria can actually just start to smell, and it gets pretty offensive. Some of the expectations that you should be prepared for with cleaning with just water would be the cleaning results themselves are dictated by the part geometry. If you have flat parts or very simple configurations, then typically the water can get to those areas and clean the coolants and the oils and some of the maybe some of the dirts off. What you will see is incomplete soil removal in blind holes and 90-degree ports and difficult areas for water itself to get to. The advantage of using a chemistry in with the water is that it lowers the surface tension of the water, allowing it to get into these areas better. And it also rinses out much better than just water. Water streaking and spotting is another area that you will have to deal with. If back to my previous page, if you don't have good quality water, then as the parts come out and dry, if they air dry or they go through the dryer, then you can see over time, you'll see streaking and spotting, which is just basically more of the contaminant that's in with the water that's hasn't been completely removed. And flash rusting of ferrous parts will be an issue to not only the parts themselves, but the actual wash tank. So you need to be prepared for that because with just water, there's no protection. So damage will incur. Some of the areas to be mindful with washing with just water is one of the biggest ones is foaming in the tank itself. Many of the coolants and the oils that are used in water wash only operations, the materials that they're used for blending, some of them are actually a soap. So when they're introduced back into water and diluted, and then pushed through a high pressure spray system, then it can generate a lot of foam. And foaming can get worse, and then foam causes foam because even though you see it on the surface, it can also go down into the tank itself. And when the intake of the spray pump starts to pull in this foam, then the pump will cavitate, and then you can cause issues to the pump itself. And foam makes foam, which just makes a mess. One of the things you can do for this is obviously add a defoamer. But if your machine is set up for full cascade, where the water is used once and then goes out the tank and goes to drain, the defoamer will just going to go with it. So unless you have a captive tank, adding a defoamer is not going to be a long-term solution. It'll be a short-term solution, but not a long-term solution. Another area of concern with just water is soil load fluctuations. If you have the end of the day or the end of the week or end of a long production run where you need to push a lot of parts through the machine, then you're going to really load the system a lot. And with just water, it doesn't have the capability of holding any of that contaminant in solution, so you can quickly load the tank itself with a contaminant. And the solution for that is to add a chemistry into the wash bath. It'll stabilize the performance. The chemistry will break down the oils and coolants and pull them into the actual solution and keep them from reapplying onto the parts. That's for sure. Another area with water only is a limited soil selection. And what I mean by that is if you're using water only, then you have to use water soluble oils or water soluble coolants. And that is, there are many of those to choose from, but there are likely others that are oil based that are probably better performing in different avenues. And same as the coolants, there are other types of coolants that would likely perform better than a water soluble coolant. And also, many of the water soluble coolants are chlorinated. So, as you introduce chlorine into a bath, then the pH can drop and it can start to affect the parts. And as I mentioned earlier, the parts and the cleaning system itself. So, once again, chemistry will actually open up your oil and coolant choices. So, if you have a chemistry in your bath, then you can use other oils and coolants that are not water soluble and still get good cleaning performance. And the final one here to be mindful of is just kind of like a recap of what I'd already mentioned is inconsistent cleaning results. It'd be one day where it may work well, and then if you have a soil load fluctuation or you've spiked it with a certain kind of oil or coolant, then the cleaning could fall off. So it's not really dependable and repeatable every day. And again, a chemistry will improve these cleaning results by keeping everything stable in the bath and consistent. There's the corrosion concerns, which are always going to be there with the water only. The corrosion to the parts being washed, of course. Um, the rusting of the cleaning system itself, and what I mean by that is the actual machine, the actual cleaning machine itself. Many of these machines are made of cold rolled steel. That you can purchase them in stainless, and some of them are in plastic, but it's not that popular. You can get them in stainless steel, but they are very expensive. So the cleaning system itself is also going to be subjected to just water, and that can cause it to rust the walls of the system, the tanks, and it just it's just a compounding problem that shortens the life of the machine. No corrosion protection post cleaning. And what I mean by that is after the parts have been cleaned and dried and they're out of the system, then they're sitting in the atmosphere, and many times without any protection, they'll start to rust. So you could have flash rusting on the parts, or in many cases where the parts are touching another part, that seems that a little bit of moisture will puddle in that area and cause a little spot of corrosion, a little spot of rust, which can, in some cases, cause the part to become a reject. And no one wants that for sure, certainly not at that point. And the wash stagnation issues is what I refer to with the carbon to keep the bath from basically smelling and going bad and becoming a bio growth. It's not only does it smell, but it's poor performing and it's just hazardous to the environment and the people around there. It's just not good. So is water actually cheaper than chemistry to use? Well, there's some things that you need to consider. The cost of water versus a captive wash tank. If you are purchasing water from your city or town or local municipality, then every time a gallon of water comes into your facility, you're paying for that. If you have a captive wash tank, then the water usage is much less. So you're able to minimize the amount of the cost itself. Excess foaming versus minimal activity foam. Now, what I mean by that is you're always going to see foam in a spray and air type system because the chemistry in the water or the materials are being aerated, so it does capture some air into it. But a correct operating machine, once you turn the power off, the foam should go down to almost nothing and relatively quickly. If you don't have any defoamer, if you're using water only, then this foam will not dissipate quickly when you turn the machine off. It only gets worse as it runs. And it can, as I mentioned earlier, it can cause problems to the machine and the tanks and then the pump itself. The rusting in the parts and the equipment that's certainly something that can be corrected with the chemistry. Many chemistries have a corrosion protection built into them, so they protect not only the parts but the equipment itself. So that's a capital investment that you need to take care of. And as I mentioned earlier, the water balance and the quality fluctuations that comes with water. There is some water balance and measuring if you're using a chemistry, but it's much less and it's a lot easier to use to perform. So to summarize, water can be used for basic cleaning operations if it's a very simple cleaning application, or if 100% cleaning or critical cleaning is not that important for your process, then water works, and that's the way you should go, and that's great. The wash and rinse bath monitoring and control is crucial to maintain a consistent cleaning operation. And if it gets out of control, it can get out of control quickly, and then you're down, and you don't want that. The soils being removed and oil separation is a very important factor. Once you remove it from the part, it's important that you also remove it or capture it in the wash tank itself. So you're not reapplying it onto the part because then you're technically not cleaning it, you're just basically moving it. And without added protection, rusting is going to be a constant problem for your parts and the system itself. So all of these things are certainly things that you'll need to consider when using water only, because there are factors that really can't be avoided. So some of the frequently asked questions that we have received are there any changes required to my cleaning system to convert to a chemistry for cleaning? Uh, the answer to that is typically no. A lot of the machines are set up to run both water and chemistry. The only area that you would want to confirm would be the seals on the wash pumps. If it was bought as a water only system, it may not have the correct seals that would be compatible to run a chemistry in. But other than that, you wouldn't need to really change anything. Everything should be the same. How important is temperature when cleaning with just water? Well, temperature is very important when cleaning with just water. It's also important when you're cleaning with chemistry. But the hotter you can get the parts, the better the soils are going to be, the easier they will be to remove. But on the adverse of that, if you get the parts very hot with cleaning with just water, once they come out of the wash section or once they come out of the dry section, the latent heat in the part can cause the parts to flash rust. So it goes back to my other concerns, my other points rather, about parts cleaning and versus parts rusting. So that's just something that you have to balance. Will converting from water to a chemistry change the amount of water I use for cleaning? Yes, it will. Absolutely, it will. Especially if you are using a full cascade machine, which is, as I had said earlier, where the water comes in from this facility, goes through the machine, is sprayed, and goes right out to drain. So that would all stop. The wash tank would become a captive tank, and the if you do have a rinse, then that would be could be captive, or that could be a cascade as well. But they typically don't use as much. The final question here is, how are cleaning chemistries typically measured and controlled in the wash tank? We found there are three common methods: pH, titration, and conductivity. The Kaizen chemistries are best measured with the conductivity. We have found that the pH strips can be set off a little bit by the coolants and the oils, and the titration kit, although it is accurate, can also be somewhat arbitrary because it's a manual process and two or three people could do it and get slightly different results. And it's also a bit of a science experiment to try to do at the sump side or on the production floor, where the conductivity meter is a simple meter with a dip probe where you put it into the tank and it gives you a number. You compare it to a concentration chart and it tells you what the concentration is. So those are very easy. So on that, I will finish my presentation and thank you very much for your time today. And I'll turn it back over to William.
Thanks, Eric. Thank you all for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who would benefit from these sessions? If the answer is yes, just go to tech2techbykaizen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.